Dr. Salman, Azhar, Dean Faculty of Civil Engineering, Chairman, Civil Engineering Department, faculty members, and dear students. I welcome you to today's seminar. Before I go into the detail of the event, I would request Asadullah to recite a few verses from Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ألم تر كيف فعل ربك بأصحاب الفيل ألم يجعل كيدهم في تضليل وأرسل عليهم طيرا نبابيل ترميهم بحجارة من سجيل فجعلهم كعصف مأكول صدق الله العظيم.
Jazakallah. Now, I would request Dr. Hassan Mushtaba to formally welcome our guest and present him with a bouquet. The title of today's seminar is Next Generation Construction Technologies and Auburn University's Masters and PhD program in Building Construction. Our speaker, Dr. Salman Azhar, is William A. Hunt Endowed Professor and Graduate Programs Chair in the McWhorter School of Building Science and Auburn University, Alabama, USA. He has more than 25 years of teaching, research, and construction industry experience by working in the USA, Hong Kong, Thailand, and Pakistan. Dr. Azhar's research area are building information modeling and advanced visualization technologies, high-performance buildings, construction safety, and construction education. Dr. Azhar has published more than 150 research papers in notable civil engineering journals and conferences. Please come on the stage, sir.
Assalamualaikum everyone. Umeed aap khairit se honge. Everyone is good. There are two parts of my presentation. For the first 35 to 40 minutes, I will be talking about some of the emerging construction technologies that are changing the construction landscape, and in the next 10 years they will impact construction projects significantly all over the world. And after that, I will give you a brief presentation about graduate program opportunities in my university. We do offer number of master's program as well as PhD program. There are scholarships available, fully funded scholarships for international students, and from the last 15 years I am recruiting 2 to 3 students every year from Pakistan who are working either for their master's degree or PhD. And some of the information which you will find out in my presentation is based on the research which I or my colleagues have conducted at Auburn University. So if you are interested in this research, then this is a great opportunity for you to apply to our program and join our research team. Alright, shall we begin? Yes. First of all, I'm going to show you some images which are created by AI. And many of you have seen these images maybe on social media or elsewhere. This is image one, another image, third one, and another one. So all these images, they show the futuristic construction sites. Let me ask you one question. In your opinion, when it will happen? When our construction sites would look something like this? Any answers? Let me ask you that. First of all, let's consider developed countries. For example, US, UK, Australia. How long those countries will take to convert their construction sites where there will be less humans and more machines? Any idea? 50 years?
10 to 20 years.
10 to 20 years. I think 10 to 20 years is a more reasonable answer. The way construction technologies are progressing, you will very quickly see that machines will be taking over humans. Just last week, I was in Las Vegas attending the 2025 Consumers Electronics Show, and there were a number of stalls of companies who are making humanoids for different kinds of jobs related to construction, agriculture, and many other fields. How about Pakistan? When it will happen in Pakistan? 50 years? Yeah,
More than 50 years.
I think 50 years is a reasonable guess. But it will happen, so it only depends, it's a matter of time. It may take 10 years, 15 years, 50 years, but eventually this will happen. Now let's a little bit backtrack. Before we talk about the future construction industry, let's discuss that what are the current problems in the construction industry. And I'm providing you some issues related to US construction industry, but they can be applied anywhere in the world. First of all, if you look at this graph, it is showing the productivity of the US construction industry as compared to all other industries in US, which includes agriculture, manufacturing, and service industries. One thing you can notice that over the period of 60 years, construction productivity in the US is not improved. It stayed more or less the same, whereas the productivity of all other industries is improved by up to 200%. So there is something wrong in construction productivity that needs to be improved. Second problem in US is labor shortages. Most of the labor in US, which includes managerial positions as well as workers, they are retiring and there are not enough people coming in the construction market. And in fact, right now, 80% of the US construction workforce is from Mexico and South America. And with the new immigration rules and all the crackdown, this situation become more worse. I can give you one example. Let's say if you are a welder in the US, you can earn up to $400 per hour. There is a severe shortage of welders in the US. And same thing, plumbers, electricians, all those trades. In fact, sometimes they are making more than the project managers. There is also an increased demand for intelligent and smart buildings and infrastructure. Also, there is a push for increased collaboration among the different project stakeholders. So in the past, the most prevalent form of delivery was design, build, which is still common in Pakistan. But in US, most of the owners, they are moving either for design build projects or another delivery system which we call as integrated project delivery. So in integrated project delivery, owner picks the designers, contractors and subcontractors in the very beginning, and they work as a team, and that collaboration helps to improve the project cost as well as its on-time delivery. And there is also a significant increase in project sizes, complexity, and scope throughout the world. Let me provide you some examples. So this is Hong Kong-Macau Bridge, which is connecting Hong Kong with Macau. It was completed in 2018 with a cost of $19 billion. Dangote Oil Refinery, which is completed last year in Nigeria, its cost is $12 billion. Hudson Yards redevelopment project in New York City, it will be completed by 2030 and its estimated completion cost is $25 billion. California high-speed rail project, which is under construction, and its estimated cost is $128 billion. And finally, Neom City in Saudi Arabia, its construction started a few years back, and its completion cost is estimated to be $500 billion. So if you go back 20 years ago and try to find out a project with cost greater than $1 billion, you may hardly find out a few projects. But right now there are over 50 projects under construction all over the world which cost $1 billion or more. So once we are working on these kind of projects, they are more complex and traditional construction methods may not work in all the cases. So the question comes that how we can build more smarter and what lessons we can learn from the other industries. So if we compare construction with the rest of the industries, the most closest industry is manufacturing industry. And manufacturing industry passed through different industrial revolutions. For example, in the 18th century when the steam engine was invented, that started the era of use of power. And then different kinds of equipment were developed. Then in late 18th century, early 19th century, the concept of mass production was introduced. In 20th century, we saw the era of computing and automation. And in 21st century, the fourth industrial revolution started, where everything is connected to everything. So fourth industrial revolution means that machines are connected with each other, they can communicate, and they can run the operations by themselves. Now in construction industry, we can also implement the same concept, and it is called as Construction 4.0. So Construction 4.0 is based on three pillars. First is digitalization, which means all the construction operations should be digitalized. Second is introduction of automation in construction processes. And third is integration of all the construction processes, so that everything is connected with another thing and there is very least amount of human interaction. Now talking about Construction 4.0 technologies, we can divide them into four groups. First group has technologies which are based on data, such as sensors, big data, cloud computing. So we can use this data to improve and control the different construction processes. Second are visualization and simulation technologies, for example, virtual reality technologies, augmented reality, laser scanning, reality capture. Third is automation and robotics. And fourth is advanced materials and manufacturing. For example, new types of materials, you may have heard about nano cements, which is a new brand of cements, and they have a very high strength as compared to traditional cements. Glass fiber reinforcement, which could replace the steel reinforcement, 3D printing and assembly prefabrication. So all falls in that group. Now in the last couple of years, you have heard the term artificial intelligence a lot. So I do not consider artificial intelligence as a standalone technology, but it can help to improve any of the existing technologies. So basically AI is everywhere, whether you look at automation, you look at materials, you look at processing, and it could help us in construction as well. Now this slide just shows you the different types of Construction 4.0 technologies, which again range from prefabrication strength as compared to traditional cements, glass fiber reinforcement, which could replace the steel reinforcement, 3D printing and assembly prefabrication. So all falls in that group. Now in the last couple of years, you have heard the term artificial intelligence a lot. So I do not consider artificial intelligence as a standalone technology, but it can help to improve any of the existing technologies. So basically AI is everywhere, whether you look at automation, you look at materials, you look at processing, and it could help us in construction as well. Now this slide just shows you the different types of Construction 4.0 technologies, which again range from prefabrication, modular construction, different materials, 3D printing, augmented reality, and so on. So in this lecture, I will be focusing on four different technologies. First is construction robotics. Second is 3D printing. Again, there are different methods for 3D printing, and I will focus on a method which is called additive manufacturing. Then third technology is called reality capture, which includes laser scanning, photogrammetry, and 360 imagery. And towards the end, we will talk about digital twins, which includes building information modeling, Internet of Things, and cloud computing. And some of the projects which I will be sharing here, these are our research projects which are either completed or they are in progress. Talking about robots, these are machines which can perform or replicate the human actions. The current construction robotics market is $3 to $5 billion, and it is expected to reach up to $12 billion by year 2034, 10 years from now. And by 2050, its size would be close to $50 billion. Now, robots could be used for different purposes. For example, first purpose is efficiency. They can make the whole process more efficient and help to improve the productivity. So in those areas where productivity is very low, they could be used to improve the productivity. They are also useful for workers' safety. So areas where workplace is dangerous or there is an imminent danger, for example, demolitions, remote inspections, robots could be used in case of humans. They are also very useful for repetitive actions which are hard on the body. So if you are repeating the same type of tasks, they can lead to different injuries. And they may also be used in areas of labor shortage. For example, I mentioned that there is a severe shortage of welders in the US. So right now, 20% of US construction companies are using robots for welding operations. Right now, most of these operations are for prefabrication, but on-site welding is also possible. So in terms of construction robots, they could be used in different areas. For example, site layout, excavation, inspection, demolition, installation. So let me provide you some examples. This is the first robot which is developed by HP, the same company who is developing printers. They call it site print, and it can be used for autonomous site layout. So if you have the site plans in terms of CAD drawings or 3D civil works or even building information modeling such as Revit drawings, you can feed it into this robot and it will lay out the exact building layout on the ground with 100% accuracy. So typically once you are doing the layout, it involves 4 or 5 humans who have to use surveying instrument to measure. This robot can perform the same task independently and in up to 50% less time as compared to humans. And its cost is very economical, so it costs around $5,000 US. So for companies, it's very attractive. Second type of robot is masonry robot. So for buildings where you are using masonry, especially as a facade, it may involve placing thousands or sometimes millions of bricks on outside. So this robot can do the same job. You can place any types of bricks on the building facade, and its productivity is 4 times higher as compared to construction workers. So this is one of the areas where I've seen many construction companies in US are actually using it. Third is called as a humanoid robot. So in US, for all the interior partitions, we use drywall, which is a wall made out of gypsum. Now the drywall installation is a very laborious process because it is available in sheets which are 4 feet wide and up to 8 feet long. You need to install them on the walls, stick them with the studs, and then based on all the electrical installations, you need to cut holes. This type of robot can perform the entire operation by itself. So it can pick the walls based on the information which is fed into it. It will place the drywall and then install it. This is another robot which could be used for rebar tying. So if you are making the rebar case or for slabs or for beams, this can place all the tie work. This is the robot which could be used for drywall finishes, so it can finish the drywall, smoothen it out, and then also paint it. These are demolition robots which could be used for any kind of demolition operations. Now in our research, 3 years ago we purchased a robot which is built by Boston Dynamics, and we call it a MAG. So this robot can be used on construction sites for different kinds of activities. Right now we are doing research for two different areas. First is autonomous laser scanning and autonomous progress monitoring. So this robot, every day it can walk the job site, it can laser scan the work which is already completed and compare it with the building information model or 3D model of the building. And it can calculate that how much work has been completed on the job site, and based on that it can also issue the job. The second area where we are using it is autonomous inventory control. In US, it's very common that at the end of the day, workers leave construction equipment, hammers or small tools on the job site. And if you calculate this total loss of tools and equipment, it is close to $2 billion per year. Now this robot, using RFID tags, it can identify any tools that are left on the job site and inform the site superintendents. So these are the two areas where we are currently doing research. We have two students from Pakistan who are working on these projects. One is from any university graduate and second is UET and NUST graduate. But if you are interested in this area, we do have a number of openings available in the coming years. So, robots, they look fascinating, but there are also a number of challenges. First is financial considerations. So right now, most of the robots, they are quite expensive. The cost starts from $5,000, but it goes up to millions of dollars. Sometimes we also face issues in integrating them with the existing workflows or with the existing systems. Another big debate in US is the safety. And it's not the safety of the robots, but the safety of the workers. How about if robots are working on the job site with humans and they get out of control or they are hacked, so what will happen on the humans? So right now there are a number of researchers which are working in this area, and similarly their maintenance and technical support is another issue. But besides all these issues, this is still a growing market, and in the next 10 years I can see a lot of companies will be using these robots. Next area is 3D concrete printing or additive manufacturing. Most of you, I'm sure, will be familiar with the name 3D printing, where we can create a complex 3D model using its building information model. Current market of 3D printers is close to $2 billion, but by 2050 it is expected to grow between $50 to $100 billion. And 3D printers could be used for different applications: prefabrication, quick construction, complex forms and shapes, and I will show you a number of examples in the coming slides. So we look at the 3D printers, we can broadly divide them into two categories. First are the printers on the left hand side, which are called as robotic arms. So it is a single robotic arm which can be used to 3D print an object, and most of the time we use these kind of robots for printing small components. They can print any component which is up to 6 feet of height. Their advantage is that they are relatively simple and cheap in cost. On the right hand side you can see other type of printers which are called as gantry 3D printers, which are based on the entire frame. They can construct a complete facility, a complete house, but on the other side they are more expensive. So depending upon the job operations, you can decide which type of 3D printer is suitable. Now let me share some of my experience with both type of printers. So this summer I visited Netherlands to visit a company, Vertigo. That company is involved in constructing 3D robotic arms which are used all over the world. They have operations in more than 50 countries. So I took my students there, we spent the whole day with them and see the construction of different types of 3D objects. For example, they printed this 3D column here. You can see here. This column is 8 feet long and they are supplying it on one of the job site. So the idea is that you can see this column shape is quite complex and it has a lot of designs on the surface. So if you try to construct this column using ordinary means and formworks, it can take a lot of time. But with 3D printing, it only took 45 minutes to complete. Now once they take it on the job site, they will place the reinforcement inside and then it will be filled with regular concrete. So here the purpose of 3D printing is to print architectural objects which are hard to construct in real life. Now this company is also collaborating with a real estate developer in a city, Eindhoven in Netherlands, and they will be constructing 50 3D printed homes in the next 2 years. And you can see some of these homes which are already constructed. So we visited one of their model house there, which is a 3-bedroom house. Its cost was, I think, close to 200 euros, which from Netherlands point of view is still very economical. Now one thing which we learned is that once you are using the 3D printing, it is not necessary that each and every component should be 3D printed. You need to pick the components which are hard to construct using ordinary methods, and you can save the cost and improve the productivity. For example, in this house, the roof is not 3D printed, it is prefabricated. And similarly, some of the interior walls are prefabricated. And they blend in everything. So this is the living room, this is the bedroom. So if you look at the bedroom, this interior wall, this is prefabricated, it is not 3D printed. This is again living room. This is office room. We also visited a 3D printed concrete bridge. So this bridge is 3D printed in small components which were placed on the job site and then they were post-tensioned. And it is in place from the last 5 years and worked perfectly without any issues. Second method which I told you is called gantry printer, where you need a full 3D printer with the frame, and its advantage is it can construct a complete unit independently. So this is one of the job sites which was in Texas, USA. We visited, so you can notice that they are constructing the outer walls, and once the walls will be constructed, they will place the reinforcement and then they will refill it with concrete for structural integrity. And every day they construct up to 6 feet high, let it dry, and then do the construction next day. So this is some. You may notice that they are placing lintels for all the openings. So this is the unit. And that's how it looked like. They decided to keep the interior finishes as it is. So this entire unit took them 72 hours to construct. Now let me give you some examples. So the same company is also working on emergency homes in Texas. So for example, if there is a natural disaster or something, these homes could be constructed in 24 hours and each house will cost $10,000, which from US perspective is very economical. This is an example in UAE, where Dubai municipality constructed the world's largest 3D printed building. This is the world's tallest 3D printed building in Riyadh, Saudi Arabia, which is built by a real estate company. This is the first 3D printed mosque in Jeddah, which was completed last year. And the main contractor was a Chinese company, and they use 3D gantry printers, and its complete construction was achieved in 6 months. In some cases, 3D printing can also be used for historical preservation. For example, 3 years ago, I visited Beijing University of Civil Engineering and Architecture, They constructed these Buddha replicas. The originals were in a very remote area and they were not in good shape, so the university constructed them at their campus. And this entire thing is constructed using 20 3D printers and consisting of 800 segments which were joined together. So on the back, there is a big scaffolding which joined all these components. And if you look here, these are my students. So if you compare the scale, you can imagine that how big this thing is. So if there is any historical building of significance which is even not present with 3D printers, we can replicate it and reconstruct it. There are some problems with 3D printers. First of all, the initial investment is very expensive. So robotic arms starts from $30,000. Gantry printers cost $200,000 or more. There are also issues with the structural integrity. For example, if the concrete is not properly cured, there are a lot of shrinkage issues which could come later on. Material consistency is an issue. So if material is not consistent, you increase the water cement ratio a little bit, or if there is air present, once you place the layers over each other, we found that they will not be consistent. And that create issues. The exteriors and interiors are rough, so either you can keep them as it is, or if you may need to finish them, and there are lack of standards. So right now, all the standardizing agencies such as ASTM, ACI, or RILAM, they have not done significant work for 3D printing standards. Third technology is reality capture technology. Reality capture is consisting of number of different technologies, but first one is a laser scanner. So this laser scanner emits laser waves. These lasers, once they strike an object, they return back immediately and they capture that part of the object. And this laser scanner emits millions of waves every second. So what happens that once we collect all those waves, they create a complete replica or digital image of the building in terms of small points, which we call as the point clouds. Later on, these point clouds could be imported into a BIM software such as Revit and converted into a 3D model. And we can view these models using augmented or virtual reality enhancements. Now, laser scanning or reality capture is a technology which is becoming very popular, and it could be used in a number of different areas. For example, if there is a renovation project and you do not have its exact or as-built drawings available, you can laser scan the entire facility. For example, if I want to laser scan the entire civil engineering department and create its 2D drawings and 3D models, I may need only a couple of days to do it. 16 to 18 hours would be sufficient to scan the entire facility. And once the drawings are available, you can add in all the renovation components and see that how they would look like before actual construction starts. Sometimes you can scan an existing building, compare it with its building information or 3D model or original drawings to make sure that no component is missing. On the right hand side here, you can see a concrete slab which is just poured, and laser scanners could be used to make sure that it is exactly labeled. There are no depressions on the concrete slab. It can also be used for automatic progress monitoring. For example, the robotic dog which we are using, it scans the building every day in the evening and it determines that how much progress has been made. And sometimes it can be used for historic preservation. For example, Notre Dame Cathedral, when it was burned in Paris, in fact, just 6 months before the fire, they completed its complete laser scan. And later on, after the fire, those laser scans were used to reconstruct the entire building. We used this technology in a number of different projects, so let me provide you some examples. First is the Salman project. So if you are aware about the civil rights history in the US, the town of Selma, which is in Alabama, is very important. This is the town where Martin Luther King started a historic long march to the capital of Alabama, which is Montgomery. And by first time this march was stopped by force. There were a number of at the time of civil rights movement, and blacks were got the rights for equal voting. So In 2020, the concerned department, they contacted our school and they wanted us to reconstruct the entire drawings of the facility, because the only drawing which was made in 1940 was this single drawing. They were going through renovations and they wanted to have complete as-built drawings. So we used the laser scanning and reality capture technologies to create the laser image of the entire bridge, and for that purpose we used the handheld scanners, tripod scanners, and some of these scanners were mounted on drones to take the image from underneath as well as over the bridge. So these are some of the images of that bridge. This is underneath. This is the 3D model which was completed using that laser scanning. And this is the complete set of drawings which we provided to the concerned department. And this entire thing took us almost 1 month to complete. And we didn't stop here. We started one of our own project where we collaborated with the history department to get the information about all those people who participated in the march. And right now we are constructing a 3D virtual reality based game where you can observe that how the march took place and information of all the people who participated in that march. This is another project which we very recently completed. Some of you may be familiar with this building. This is Petra in Jordan. This is a UNESCO heritage site constructed I think somewhere in BC. And right now, as a tourist, you can only see it from outside. There are a number of rooms, but due to they are not in good shape, so the government decided not to allow the visitors to go inside. So we collaborated with the tourism department of Jordan to laser scan all the interiors of Petra and then create a 3D virtual image which people can visit either by going to their website or by buying the virtual reality app. So the entire scanning operation took us 3 days to complete. So these are some of the images of that laser scan. So this is showing you a walkthrough model that also shows the interior. So visitors cannot pass this area. So we were lucky to go to that area and also scan it. You might be able to see there are a number of cracks in the structure. This is entirely made out of stone, but due to cracks and structural integrity issues, they do not allow any visitors to go inside. But as a visitor now, this work is completed, so you can go to tourism website and see that how the facility looks like. Another project which we completed with a collaboration of University of Valencia in Spain. This is a historic church which was built in the 14th century, and we again laser scanned the entire church, interior and exterior, and then created its 3D virtual reality model. So these are some of the images. Now, reality capture is a great technology, but it also has a number of challenges. First is the time consuming. I think the power, it is not connected with power. While you connect, let me carry on. So, reality capture technology has one issue, that it creates a lot of data. Sometimes it consists of millions and billions of data points. So processing those data points and converting them into a useful 3D image takes a lot of time. So we are working in this area using artificial intelligence. In fact, I have a student from Pakistan who is developing a AI-based algorithm which can automatically convert point clouds into their respective 3D models. So that's one issue. The second issue is the cost of the technology. 10 years ago, when laser scanners were introduced, they were very costly. When our department purchased the first 3D scanner, cost was close to $50,000. But now with the passage of time, cost is reducing. So right now, one of the laser scanners which is developed by a company Faro, you can procure it in $5,000. So they are much more economical. We also need some training and technical expertise. So in our department, we are offering a number of courses on construction informatics for our master students and PhD students. For example, for laser scanning, we offer a course, reality capture technologies, which is a 3-credit-hour course, and you learn everything about laser scanning. We are also offering a course on robotics. We very recently developed a course on artificial intelligence and machine learning. So there are a number of courses which we offer to our students. Last technology is called as digital twins. So digital twin means that you can create a digital replica of a building, and this replica can communicate with the original building. It can get the information from that building, all the data, and then it can help the building to better automate its operations and streamline them. So that's what you can see here, that we have an actual building and its digital replica, and they are communicating with each other using sensors, Internet of Devices, and to streamline the building operations. Now, digital twins could be used in a number of different cases. One example is the entire campus of Nanyang Technical University in Singapore. So this university developed a digital twin of the entire campus, and they used that digital twin to optimize the building operations and its energy usage. Do not allow any visitors to go inside. But as a visitor now, this work is completed, so you can go to tourism website and see that how the facility looks like. Another project which we completed with a collaboration of University of Valencia in Spain. This is a historic church which was built in the 14th century, and we again laser scanned the entire church, interior and exterior, and then created its 3D virtual reality model. So these are some of the images. Now, reality capture is a great technology, but it also has a number of challenges. First is the time consuming. I think the power, it is not connected with power. While you connect, let me carry on. So reality capture technology has one issue, that it creates a lot of data. Sometimes it consists of millions and billions of data points. So processing those data points and converting them into a useful 3D image takes a lot of time. So we are working in this area using artificial intelligence. In fact, I have a student from Pakistan who is developing a AI-based algorithm which can automatically convert point clouds into their respective 3D models. So that's one issue. The second issue is the cost of the technology. 10 years ago, when laser scanners were introduced, they were very costly. When our department purchased the first 3D scanner, cost was close to $50,000. But now, with the passage of time, cost is reducing. So right now, one of the laser scanners which is developed by a company Faro, you can procure it in $5,000. So they are much more economical. We also need some training and technical expertise. So in our department, we are offering a number of courses on construction informatics for our master students and PhD students. For example, for laser scanning, we offer a course, reality capture technologies, which is a 3-credit-hour course, and you learn everything about laser scanning. We are also offering a course on robotics. We very recently developed a course on artificial intelligence and machine learning. So there are a number of courses which we offer to our students. Last technology is called as digital twins. So digital twin means that you can create a digital replica of a building, and this replica can communicate with the original building. It can get the information from that building, all the data, and then it can help the building to better automate its operations and streamline them. So that's what you can see here, that we have an actual building and It's digital replica, and they are communicating with each other using sensors, Internet of Devices, and to streamline the building operations. Now, digital twins could be used in a number of different cases. One example is the entire campus of Nanyang Technical University in Singapore. So this university developed a digital twin of the entire campus, and they used that digital twin to optimize the building operations and its energy usage. So as a whole, they were able to achieve 31% energy savings because the digital twin was identifying the patterns of energy use. They were also determining when the building is occupied or when it is not, and savings are close to $5 million per year. This is East Hospital in Shanghai, China, where they developed digital twin, and they are using it for a number of areas. For example, this is their digital twin operation center. They are using it for energy management of the building, for facilities management. So if there is any problem, the digital twin can identify the issues and it could be easily fixed. They are also using it for security systems. That's another example of Stava Bridge in Norway, which was a historical bridge. So this bridge was more than 100 years old, and they installed these sensors to operate, to determine the traffic levels and interior stresses inside the bridge. So on one day, this bridge issued a distress signal to the transportation department, and they found that the stress levels in some of the columns is much higher than could be allowed. So they immediately stopped the traffic on that bridge. And within 45 minutes of stoppage, part of the bridge was collapsed. So due to this technology, they were able to make sure that no human lives were suffered. And this last project, which is under construction and it is carried by Cambridge University, they call it digital roads. So in road construction, no matter they are in Pakistan, US, UK, everywhere, one of the biggest problem is potholes. Once you use the road due to temperature and stresses, potholes are very common. So the idea of this project is that there will be an autonomous vehicle who will be just riding on the roads, and it will identify any potholes. And that information will be transferred to their central hub, and there will be a repair unit that will go and automatically repair it. So for this project, they are not only building the automatic machines, but also different types of materials which can quickly fill the potholes. So this project is in progress, and by 2035 it will be completed and implemented. So again, digital benefits offer several benefits: better planning, better decision making, but at the same time they are expensive, there are security issues, and there are also data integration issues. Now to wind up this presentation, I would like to just give you some of my final thoughts. That these technologies are emerging, so most of them will be implemented anytime from 5 years up to 50 years. One of the biggest issue or biggest roadblock is their high implementation cost. But with every technology, we have seen that the cost is high, and as we start to implement, cost starts to reduce. So same thing is happening here. There is also a lot of training needs. So students and workers, whoever is using the technology, they need to be able to use it. So 5 years ago, in fact in our department, this was one of the issues which was raised by the construction industry. So we went through and we revised our entire curriculum, and it is right now based on Construction 4.0. So we are teaching those courses and those technologies to our students, which they maybe need to implement once they go into the field, or maybe 5 or 10 years from now. And right now, technology is available everywhere. You can learn by yourself. So for example, if any thing is not taught, you can go to internet, you can find out hundreds and thousands of YouTube videos. There are a lot of free certification, free courses available and offered by different universities. So I will strongly suggest you to learn these technologies, because if you want to get a higher degree or you want to work overseas, you must have good knowledge about these technologies. There are also technology limitations, so all these technologies are not perfect, but with time things will improve. Some people raise the question that if technologies overtake humans, then what humans will do? So I would answer that humans' jobs always change over time. For example, 50 years ago, for the street lamps, people were hired and their job was to go and turn on the street lamps. And even sometimes, 3 years ago, I was in Ghana, I've seen that there is a light switch on each street light and someone goes in the evening and turn on the switch lights. But in most of the countries, we don't have that job present. So similarly, when robots will take some of the operations, then humans will still be relevant and their job would be to work with the robots and control all the operations. And maybe there are new jobs which are created for humans. So there is some resistance to change, but once the technology is available, then that resistance melts down. So we talked about construction 4.0, industry 4.0, but at the same time, work is started on the next generation, which is industry 5.0. So I thought to share one slide with you. So industry 5.0, in fact, very interestingly, it will be based on three things. First is sustainability. So we have done a lot of development, but due to climate change and other reasons, we have to go back to the nature. So one of the pillars for next generation technology is that the products and facilities would be more sustainable. Second is resilience. So we have to make sure that whatever we are building, it is resilient to natural hazards. We have seen that natural hazards have increased a lot during the last 20-30 years due to climate change. We have seen floods, wildfires. Right now, you may be aware that in Los Angeles there are wildfires which are still not controlled, earthquakes. So we have to construct those structures which are more resilient to all those natural hazards. And third thing, new technologies will be human-centric. So they will not replace humans, but they will be controlled by humans. So for Industry 5.0, some of the pilot projects are already in progress, and by 2030, some of the companies, they will start to implement it. So that's all about this presentation. I have listed my email address. So if you have any questions, you can always contact me through email. Now I believe that if we have 5 minutes, I would like to quickly provide you some information about our graduate programs. Find out the presentation. So here on this side, you can see two things. On the left hand side, our students are compacting the concrete using rollers, and this is our information technology class where they are learning about construction robotics. So one good thing which distinguishes our program from the rest of the program is we focus both on traditional technologies as well as the emerging technologies. So if you are a student in our program, you will get an opportunity to learn both type of technologies. So Auburn University is located in a small town called Auburn, which is at the border of state of Alabama and Georgia. We are around 100 miles west of Atlanta, which is the largest city in the southeast. And Auburn University is a public university, what we call as the land grant university, which means the land was granted by the US government, federal government, to construct the university. It is more than 150 years old. In terms of its ranking, it is among Carnegie R1 research ranking universities. So R1 is the highest research rank for US universities, and Auburn is one of them. And in terms of its overall ranking, it is currently 42nd among the different US universities. Our student enrollment is 34,000, which includes more than 5,000 graduate students, and we have 14 different colleges or faculties. So our program is in the College of Architecture, Design and Construction, which was established in 1907, more than 100 years ago. And it consists of 3 schools: School of Building Science, where I teach, it's a construction management program; School of Architecture, Planning and Landscape Architecture, they offer programs in architecture, town planning, landscape architecture and interior design; and School of Industrial and Graphics Design, which offer degrees both in industrial design and graphics design. And in fact, very interestingly, they also have another program which they call as the Prison Arts Program. So we have 2 faculty members who go to different prisons and teach prisoners graphics design and product design. And Quantum School of Building Science, it was established in 1945, and it is the Prison Arts Program. So we have 2 faculty members who go to different prisons and teach prisoners graphics design and product design. And Quantum School of Building Science, it was established in 1945, and it is the second oldest construction management program in the US. The first oldest is University of Florida, and second oldest is our one. We have currently more than 600 undergraduate and graduate students in our program, 21 full-time faculty members, we have number of labs, and we offer degrees in building construction at undergraduate, master's and PhD level. So what our graduates typically do, they can do both office and field jobs. Office jobs include working as an estimator with contractors, schedulers, pre-construction manager, virtual design or construction manager if you are interested in construction informatics or in their business development divisions. Field jobs include project managers, site superintendents, field engineers, safety managers, quality control managers. So these are all different roles you can take. Our employment rate during the last 10 years is 100% for domestic students and 95% for international students. And all the students from Pakistan, they were able to get jobs. Average salary is close to $75,000, and our students, they get jobs almost everywhere in US. So Master of Building Construction is a 1-year program with an emphasis on commercial construction. So it includes commercial facilities, sports stadiums, plazas, office buildings and so on. We take 1 cohort every year that starts either in summer or fall. Our program size is relatively small, so we admit 15 to 18 students per year. And the main idea is to give individual attention to all the students. And most of our students, they do not have an undergraduate degree in construction management. Rather, they have degrees in engineering, such as civil engineering, or architecture, or sometimes in business. And they are interested to pursue career in construction. So this is our curriculum model. Now, most of you here in this room have undergraduate degree in civil engineering or architectural engineering. So you will fall in this category. So you will join us in the summer semester, and in the first semester you will take a series of foundation courses to learn the US construction terminology. You will also learn about basics of construction. So there are a lot of things which you may not have learned here, and these foundation courses will provide you an opportunity to learn. And then for the next 3 semesters, you will be taking a series of core courses, electives, and then you will work on your thesis. There is also an option that in the 4th semester you may go for internship with a construction firm and then return back. Now, one good thing is once you complete the master's degree in US, every international student gets the work authorization, which is called as OPT, optional practical training, and you can work up to 3 years in the US without any work visa. And during those 3 years, if the construction company is retaining you, you can apply for permanent residency or green card. So you do not need to go through the route of H-1B visa, which is more competitive. So all the students from Pakistan, as I told you, that they got jobs, and many of them already received their permanent residency or citizenship. We also have a number of study abroad opportunities. So every year I take students, both undergraduate and graduate, and we visit different countries and learn about their construction. For example, these are some of the pictures where I took students to China as well as Europe, and there are a number of study opportunities that will be available to you. So admission requirement says your undergraduate GPA should be 2.75 or it should be 3.0 in the last 2 years. GRE is required and minimum score is 295. This is in fact old presentation, so during the COVID time we waived GRE, but right now it is required. And we require 3 letters of recommendation, a statement of purpose, which is like a 2-page essay why you are interested in getting a master's degree, and your current resume. We offer a number of graduate assistantships, which means that you may receive a 100% tuition waiver plus a monthly stipend. And every year from Pakistan, I try to recruit up to 2 students with full scholarship. So that's a great opportunity for you, because if you need to pay for this degree, it will cost you around $80,000. The cost of tuition for international students in US is between $16,000 to $18,000 per semester, plus cost of living. So if you're getting a full scholarship, you can convert in Pakistani rupees to how much money it would be. We also send our students in different national and international competitions, and all is funded by the school. You can also participate in different professionals and honor societies, and if your research is published, we will fund you to go to different conferences and present your research. We also have a PhD program which is relatively young. It was started in fall 2019, and right now we have 11 students in that program. Out of 11, 3 students are from Pakistan. PhD program takes 3 to 4 years to complete. You must have master's degree to apply. We normally take 2 to 3 students per year, both part-time and full-time. And again, these are the requirements. So I distributed one flyer about our program. If you are interested to learn more about it, there is a QR code which will take you to our program website. And if you have any questions, you can always contact me through email, and I would be more than happy to help you. And it is not necessary that you only apply to Auburn University. There are more than 140 construction management programs in the US. So I would suggest you to explore other programs and try to apply to multiple programs. If you plan to apply to another university and you need some piece of advice, always feel free to contact me and I will be happy to answer. Only one thing where I will not help you: do not contact me and ask me that what should be the topic of my thesis. That you need to find by yourself. Because a lot of students contact me and ask just a topic. I can tell you that whenever you do a research, 50% of your effort is to find out a topic. And once you do the topic, it's not just finding out a topic, you will learn about the entire body of knowledge, and that will help you to better understand the topic. If I tell you a topic, you do not have any understanding, you may pick that topic, but then you will struggle to finish the topic. So that's all about my presentation. I would be happy to answer any questions if you have. कोई क्वेश्चन जो आप पूछना चाहें? जी।
सर एक्चुअली आपने स्टेटमेंट ऑफ पर्पस में मेंशन किया था कि आपके लॉन्ग टर्म और शॉर्ट टर्म गोल्स होने चाहिए। सर लॉन्ग टर्म से गोल आपके मैनेजमेंट जाने के हैं तो, बट सर इस प्रोग्राम में रोल होने के लिए आपकी शॉर्ट टर्म गोल्स क्या होने चाहिए?
ठीक, लेकिन जो स्टेटमेंट ऑफ पर्पस है, फर्स्ट ऑफ ऑल इट इज़ वेरी वेरी इंपॉर्टेंट, क्योंकि यूनिवर्सिटीज़ में लेट्स से कि हमारे पास 100 एप्लीकेशंस होती हैं, तो एक चीज़ जो कि हम ज़रूर पढ़ते हैं वेरी केयरफुली, दैट इज़ द स्टेटमेंट ऑफ पर्पस। उससे एक तो हमें पता चलता है कि स्टूडेंट की जो टेक्निकल राइटिंग है वो कैसी है, और स्टूडेंट का विजन क्या है, और वेदर दैट स्टूडेंट वुड बी सक्सेसफुल और नॉट। ए गुड स्टेटमेंट ऑफ पर्पस जो है बेसिकली इट शुड कंसिस्ट ऑफ 3 थिंग्स। फर्स्ट ऑफ ऑल, मे बी इन 1 to 2 पैराग्राफ्स आप अपने आप को ब्रीफली इंट्रोड्यूस करें कि आपकी अंडर ग्रेजुएट डिग्री किस फील्ड में थी और आप क्यों गए। लेट्स से कि अगर आपने अंडर ग्रेजुएट सिविल इंजीनियरिंग में ली, तो व्हाई यू सिलेक्टेड सिविल इंजीनियरिंग, व्हाई नॉट माइनिंग और व्हाई नॉट इलेक्ट्रिकल। और जो उसमें आपकी अकॉम्प्लिशमेंट्स हैं एज ए स्टूडेंट उसको हाईलाइट करें। उसके बाद सेकेंडली मेंशन करें कि व्हाई यू आर अप्लाइंग टू ए स्पेसिफिक यूनिवर्सिटी। लेट्स से कि अगर आपने ऑबर्न यूनिवर्सिटी अप्लाई किया या नॉर्थ कैरोलिना यूनिवर्सिटी अप्लाई किया तो व्हाई दैट यूनिवर्सिटी, देयर शुड बी ए रीज़न, तो ट्राई टू हाईलाइट दैट रीज़न। उसके बाद जो शॉर्ट और लॉन्ग टर्म गोल्स हैं उसमें यह है कि व्हाट यू वुड लाइक टू सी योरसेल्फ इन द नेक्स्ट 5 years। लेट्स से वंस आप प्रोग्राम से ग्रेजुएट होते हैं तो यू आर इंटरेस्टेड टू वर्क विद ए कंस्ट्रक्शन फर्म। अगर आप कंस्ट्रक्शन फर्म के साथ काम करना चाहते हैं तो व्हाट रोल यू आर एंटिसिपेटिंग, whether you want to become a project manager or site superintendent, या अगर आप वर्चुअल डिज़ाइन में इंटरेस्टेड हैं तो व्हाट वुड बी योर एरिया। और सेकेंडली यू माइट बी इंटरेस्टेड इन PhD, तो यू मे मेंशन दैट। और उसके बाद लेट्स से कि 10 years or 20 years from now where you see yourself, maybe you want to set up your own construction company, you may want to progress through the ranks of existing construction company and reach at its top. Sometimes you may mention the name of the construction companies, or it might be possible that you want to get a PhD and work in academia. उससे हमें ये पता चलता है बेसिकली स्टेटमेंट ऑफ पर्पस से कि स्टूडेंट कितना डिटरमिन्ड है, उसको कितना आइडियाज़ हैं और उसको क्या वो करना चाहता है। और मेक श्योर कि जब आप स्टेटमेंट ऑफ पर्पस लिखें तो वेरी केयरफुली रीड इट। समटाइम्स ये होता है कि स्टूडेंट एक स्टेटमेंट ऑफ पर्पस लिखते हैं विच दे सेंड टू 20 यूनिवर्सिटीज, और इन मेनी केसेस वो यूनिवर्सिटी का नाम भी चेंज करना भूल जाते हैं। तो जब हम फर्स्ट स्क्रीनिंग करते हैं उसमें ये इस टाइप के जितने स्टूडेंट्स होते हैं हम सबको हम स्क्रीन आउट कर देते हैं, चाहे उनका कितना भी अच्छा GPA या GRE स्कोर्स ना हो। सेकेंडली ये है कि नाउ विद AI और चैट GPT इट्स वेरी इजी कि आप चैट GPT से लेटर लिखवाएं। तो as long as you are using chat GPT to improve your language, it is fine, but don't provide the pointers to chat GPT and ask it to create the full letter for you, because there are a number of ways जिससे हम आइडेंटिफाई कर सकते हैं कि स्टेटमेंट ऑफ पर्पस या कवर लेटर जो है ये स्टूडेंट ने लिखा है या इट इज रिटन बाय चैट GPT। देयर आर आल्सो सॉफ्टवेयर्स अवेलेबल which can determine with a certain degree of confidence कि ये AI generated content है। तो try to write it by yourself, then you can go to ChatGPT and ask that correct the grammatical mistakes. As long as you are using ChatGPT for correcting grammatical mistakes or correcting the syntax, it's fine. Secondly, it's very important कि जो minimum requirements university की हैं, whatever they are, try to fulfill them and don't ask for any waivers. मेरे पास काफ़ी स्टूडेंट्स कांटेक्ट करते हैं कि GRE वेव हो जाएगा या IELTS वेव हो जाएगा। तो फर्स्ट ऑफ ऑल तो अगर आप कॉम्पिटिटिव हैं, यू आर अप्लाइंग फॉर स्कॉलरशिप, तो उसमें कोई किसी टाइप का हम वेवर नहीं देते। लेकिन जब स्टूडेंट्स हमसे कांटेक्ट करते हैं इस टाइप के वेवर्स के लिए तो इट आल्सो टेल्स मी कि ये स्टूडेंट बहुत ज़्यादा इंटरेस्टेड नहीं है, बहुत ज़्यादा डिटरमिन्ड नहीं है। क्योंकि अगर आप ये एग्जाम्स दे रहे हैं विद सीरियसनेस तो इट मीन्स यू आर डिटरमिन्ड। तो नॉर्मली जब स्टूडेंट्स वेवर के लिए पूछना शुरू करते हैं तो उसके बाद आई डोंट पे मच अटेंशन अंटिल दे कंप्लीट द एग्जामिनेशंस, सो देयर आर नो वेवर्स। तो इनफैक्ट अगर आप वेवर्स के लिए कॉन्टेक्ट करते हैं तो इट विल नॉट क्रिएट ए गुड इंप्रेशन ऑफ योरसेल्फ। जो जिस प्रोग्राम में भी आप अप्लाई कर रहे हैं उनकी जो भी टर्म्स एंड कंडीशंस हैं उनको बहुत केयरफुली स्टडी करें। मेक श्योर कि आप उनकी मिनिमम रिक्वायरमेंट्स को मीट करें लेकिन उससे ऊपर जाएं। फॉर एग्जांपल जो हमने स्टूडेंट्स को लास्ट ईयर स्कॉलरशिप्स दिए थे तो उनका जो एवरेज GRE स्कोर था इन वर्बल एंड क्वांटिटेटिव इट वाज बिटवीन 315 to 325। 294 इज आवर मिनिमम रिक्वायरमेंट, लेकिन ऑफ कोर्स के उससे हायर था। इन टर्म्स ऑफ GPA जो आई थिंक 3.41 वाज द लोएस्ट GPA जिस स्टूडेंट्स को हमने फुल स्कॉलरशिप प्रोवाइड किया। तो मेक श्योर कि आप उनसे जो भी कंडीशंस हैं उनको करें और अपना पैकेज जो है वो बहुत केयरफुली बनाएं, जो भी डॉक्यूमेंट्स आपने भेजनी है, क्योंकि एक अच्छा पैकेज बनाने में भी तकरीबन आपको 3 से 4 महीने लगेंगे। इट्स नॉट समथिंग कि आप ओवरनाइट उसको बना लें। तो डू इन्वेस्ट सम टाइम एंड देन यू विल सी द बेनिफिट्स। ठीक है, और कोई क्वेश्चंस? ठीक है, चलिए एग्जाम को बहुत केयरफुली स्टडी करें। मेक श्योर कि आप उनकी मिनिमम रिक्वायरमेंट्स को मीट करें लेकिन उससे ऊपर जाएं। फॉर एग्जांपल जो हमने स्टूडेंट्स को लास्ट ईयर स्कॉलरशिप्स दिए थे तो उनका जो एवरेज GRE स्कोर था इन वर्बल एंड क्वांटिटेटिव इट वाज between 315 to 325. 294 is our minimum requirement, लेकिन of course के उससे higher था. In terms of GPA, so I think 3.41 was the lowest GPA जिस students को हमने full scholarship provide किया. तो make sure कि आप उनसे जो भी conditions हैं उनको करें और अपना package जो है वो बहुत carefully बनाएं, जो भी documents आपने भेजनी है, क्योंकि एक अच्छा पैकेज बनाने में भी तकरीबन आपको 3 से 4 महीने लगेंगे. इट्स नॉट समथिंग कि आप ओवरनाइट उसको बना लें. तो डू इन्वेस्ट सम टाइम एंड देन यू विल सी द बेनिफिट्स. ठीक है, और कोई क्वेश्चंस? ठीक है, चलिए, अगर कोई क्वेश्चंस नहीं है तो मेरा ईमेल आपके पास है, तो ईमेल करें. लेकिन जब भी ईमेल करें थोड़ा सा अपने आप को इंट्रोड्यूस करें कि आप क्या कर रहे हैं, किस सेमेस्टर में हैं और कब आप अप्लाई करना चाहते हैं, और वट एवर हेल्प आई कैन डू आई विल डेफिनेटली डू इट. ठीक है, थैंक यू.
Thank you very much, sir, for this excellent talk. Now, I would request Professor Dr. Asif Hamid to please come to the podium and give some concluding remarks.
Bismillahirrahmanirrahim. The chairman sir is not here; he is abroad, and currently Kaisab is the chairman, but he is not feeling well today, so he could not attend the seminar. Dean sir has to attend this the meeting with the chief minister. Anyhow, I was in the VC office to attend another meeting on the training for our students on the AI generative AI. So we could not welcome to you in that way, sorry. But anyhow, Salman Azhar, Dr. Salman Azhar is our proud alumnus of Civil Engineering Department UT Lahore. He is currently working as the chair and the professor in the Open University, and we are very thankful to him that this is the second time he came here and have a talk with you people on advanced technologies. He's expert in the building information modeling. Today he has discussed with us the laser technology and also the 3D printing. So again, we are very thankful to you that you came here, and at the end, I will not take your time. At the end, I request you to give a big round of applause for him. Dr. Salman Azhar always not only share the advanced technologies in the world, but also give the motivation to you, to our students. And I think, sir, your session was 90. He was 90. His 35 years back, he was sitting on the same benches. He was a student. He did the bachelor degree from the same university, from the same department. Now he is a very successful person, and I hope that you will have the inspiration from Dr. Salman Azhar, and you after a few decades you will be also standing on the podium, and we will see many Salman Azhars from among these students. Thank you very much, and once again give the clapping and thank you very much.
Now, I would request Professor Dr. Asif Hamid to please come to the stage and present the shield to our guest.
Azhar.
All participants are requested to join for the group photo.
ये e-commerce से शुरू कैसे वो कराओ बस